This is Quick Clip 3.02, Chemical Reactions, and in this lesson we're concentrating on the signs that a chemical reaction has occurred. So first, let's take a look at an example of a chemical reaction. On the left, we see two atoms or a molecule of hydrogen. We have a molecule of oxygen made up of two atoms, and these are called the reactants. The reactants are the substances that are used in the reaction before the reaction occurs. So it's the two items that we combine together. And then the result is going to be H2O2, which is something called hydrogen peroxide. Now, in a chemical reaction, the bonds break in the hydrogen and the oxygen, and they move across the reaction and they form an entirely different molecule. In this case, H2O2, also known as hydrogen peroxide. So it's important to understand that the molecules of the reactants, the bonds break, and then they're reassembled to make a new product on the other side. And again, the products are the substances created by the reaction. So in a formula, you'll see the reactants on the left, usually, and the products on the right. Now, going into signs of a chemical reaction, looking at something, how do you know that a chemical reaction has occurred? One is a change of color, and the one that I want to point out is the one that you're most commonly familiar with, something called rusting or oxidation, where the metal is reacting with oxygen. And so we have the before and after here, where we have the wrench rusting out, and you can see the before on the right and the after on the left. And then the bolt, the metal bolt, before and after, we have the before nice and clean on the right, and then on the left all rusted out. Some other examples include bubbles forming, and you can see here this woman is placing a Mentos tab inside the Coca-Cola, not realizing what will occur, and the reaction is very quick and violent. Kind of like that picture. Next, we have a change in odor. So if you've ever, smelled something cooking in your kitchen and, baking a cake or making a pot of soup like we have here, that's an indication of a chemical change. So whenever you're cooking something, you're creating a chemical change. And another sign of a chemical reaction is the formation of a precipitate. Now, precipitate is when you add chemicals together and a solid forms. And you can see that they're dripping in a chemical into another, and it's forming this white precipitate or a white solid inside of the liquid. So bubbles forming, change in odor, or formation of a solid. Next is temperature change. And so oftentimes when there's a chemical reaction, the mixture itself will become hotter or colder. And so here, if it is an exothermic reaction, then heat is released and the substance becomes hotter. So you can see the thermometer here. So exothermic, it's releasing heat, it's creating and releasing heat, and so the substance is becoming hotter. The other type of temperature change is called endothermic, and here the heat is absorbed and it's getting colder. So it's taking away heat, and it's making it colder. And so you can see the thermometer and the temperature drop in the animation there. All right, so temperature change can be exothermic, heat being released and getting hotter, or endothermic, heat being absorbed and getting colder. Those two terms can be very confusing. So take time to make sure you understand those two terms. And so to review chemical reactions, the basic signs are one, change in color, like something like rusting, or the other term for that is oxidation. Something, when something has bubbles, that's a signification of gas forming. That's a sign of a chemical reaction. Change in color, change in odor. If something is changing and it smells different, that's a sign of a chemical reaction. And then formation of a precipitate. That's when a solid forms inside of the mixture where there was no solid before. And then finally, a temperature change. And again, exothermic is when energy is released and it's exiting, right? Exotherm, and the heat is exiting, it's becoming hotter. Endothermic, it's going in, in, and it's absorbing heat, and the substance is getting colder. All right, thanks for watching.